morning all of you. I am Tanushri Dalai from Civil Engineering branch, and today I am going to teach you your Theory 1 paper, which name is Structural Mechanics. So in the previous class we discussed about principal stress, principal strain and various kind of normal plane and oblique plane. Then we studied about the body subjected to stress system, that is in 2D system and in the 3D system. And we just initiate 4 kinds of criteria by which we can calculate the normal stress, tangential stress, resultant stress and the angle of obliquity, and also we can determine the maximum shear stress. So these are the 4 criteria. In the first figure, it is subjected to one plane and one kind of stresses in the x-axis only. So the stress are known as sigma 1. And the second case is, here the stress are applied both mutually perpendicular plane. That means one is your x-axis plane and second one is your y-axis plane. Then in the fourth figure, here the object is subjected to only shear stress. That means here you can see only tau is there. Here sigma 1, sigma 2 are not provided, only shear stress is subjected. Then come to the fourth one. It is the combination of all these 3 stress system. That means the stress along the y-axis, the stress along the x-axis and as well as the stress of shear. Okay. So next one is your, for the uniaxial stress system in an oblique plane, how you will determine the value of normal stress and shear stress. See, in case of normal stress in the uniaxial stress system, you have to understand this diagram. That means this is your body, okay, and it is subjected to 2 tensile forces here, and this is the angle of obliquity. You can see that the theta value over here, and it is make an angle with major axis, or you can say vertical plane. So this value is your theta value. Okay, and this is the tau value. You can see here, this is the tau value. Okay, so how you will determine? The formula is sigma n equal to p by a cos square theta. So p you can find out from this value and a you can find out from this object size. Then theta is your, this value is your theta. Okay, so you just put all this value over here and find out the sigma n value. In this way, you have to determine the value of shear stress, which is denoted as tau, and tau equal to p by 2a sine 2 theta. Okay, by this formula you can got your tau value. Then for the shear stress value, how you will know that what kind of shear stress is in positive value and what kind of shear stress is in negative value. So you can see here the first figure, this figure and this figure. Always remember, while a object is subjected to a shear stress, then it is always opposite to each other in one plane. That means if I say that here it is the object and in the upper side here one shear stress is there, and at the lower side here another shear stress is there, and you can see that all the shear stress are opposite to each other. That means it is directed to the right side and the lower one is directed towards the left side. That means here the shear stress give a clockwise movement. That means if we consider this shear stress, then it give a moment this type. Okay, and if we consider the lower part of the shear stress, then it will give this kind of moment. So in total it will give a clockwise moment. Okay, the clockwise moment is this type. So for the clockwise moment, the shear stress value is positive. Okay, for the clockwise moment, the shear stress value is positive. And how we will get the shear stress is negative? So look at the second figure, this figure. So you can see at the left side of the section, the shear stress is downward direction, and at the right side of the section, the shear stress is in upward direction. So if we consider this shear stress or this shear stress, it will give the moment about this kind of moment it will give. And here in the second figure, for the upward shear stress, it will give this kind of moment. Okay, so as a whole, the moment is like this kind of, and this moment is known as your anti-clockwise moment or counter-clockwise moment. Okay, with respect to the center inside of the element. Okay, here also it is give a clockwise moment, and here it will give a counterclockwise moment. So while the shear stress is in counterclockwise, then you can take it as negative sign. Okay. So now comes to normal stress and tangential stress of various kinds of criteria. Okay. So first of all, first criteria is the stresses in two mutually perpendicular direction with a simple shear stress. Okay, that means the figure is like, here you can see the fourth figure is about this criteria. So here you can see the mutually perpendicular stresses is there. That means the sigma 1 and sigma 2, and with the shear stress also. Here you can see the tau also there. So due to this criteria, what is the value of normal stress and tangential stress? See, the normal stress equal to sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 cos 2 theta plus tau sin 2 theta. That means the sigma 1 is the stresses along the x-axis, and x-axis is your major axis. Then sigma 2 is your stresses along the y-axis, or it is known as the minor axis also. And theta is the angle between oblique plane with the major axis. Okay, and tau is the shear stress of the object. So you just put the value and find out the sigma n. In this way, the formula for tangential stress is sigma 1 minus sigma 2 divided by 2 sin 2 theta minus tau cos 2 theta. Okay, and also you can determine the major principal stress and minor principal stress. The major principal stress means the maximum value of stress in the principal plane, and the minor principal stress means the minimum principal stress in the principal plane. Okay, so you can find out the major principal stress by evaluating the formula sigma 1 plus sigma 2 divided by 2 plus root over of sigma 1 minus sigma 2 divided by 2 to the power 2 plus tau square. And in the minor principal stress, you just put this formula, only you change the positive value as negative. Otherwise, the formula of the major and minor principal stress are equal. Okay, so this is all about normal stress and tangential stress for the direct stress in two mutually perpendicular directions with simple shear stress in 2D system. This is only for two-dimensional system, and this is also known as complex stress 2D system. So today this much. Thank you so much. We will discuss other thing in the next class. Thank you.